So today we are going to talk about how to find the longest palindromic subsequence. So the question says, given a string X, find the longest palindromic subsequence length in X. A subsequences is a sequences that can be derived from another sequence by deleting some or no elements without changing the order of the remaining elements. So first, what is a palindromic? Pretty much is like when we have a string and the reverse of the string can be equal to the original string. So for example, we have x as string equal b. And the longest palindromic subsequence is b. The reason why is this, because when we get rid of 8 and the rest of the remaining character can be formed palindromic, and it gives us the longest length. And the second example is the string is CBBD, and the answer, the output is 2. And the reason why it is because we get rid of character C and D, and it remains B and B, and when we reverse it, it's still B and B, and they're the same. So I'm going to show you my whiteboard and explain for you how we can get the longest palindromic subsequences. I'm sure. So I draw a table that produced by the string BB. So pretty much we actually do not need to consider all the entries in this table. We only need either the left side or the right, the left side or the top side from the diagonal. So start from here. Here is 1, 1, 1, 1, 1. So I put all 1 on the diagonals. The reason why it's all 1 because when our starting point start from here, and the length of the palindromic is 1. When we start from here, is also 1. And here, this is 1. A and A, they are the same. So it's 1. B and B, they're the same. So it's 1. So we either consider this corner or consider this corner. They are eventually the same. So, and then how we fill out our tables. So I'm going to give an example. Like, for example, our endpoint is 8. Now our starting point is 8 and endpoint is 8. And we know this A and A, they're the same, and it's palindromic. But we only know the starting point and end point. We cannot guarantee what the middle it is. So we need to like check what the middle is. So if we one step forward for 8, that will be I plus 1, and then here is J, and one step back, that will be J minus 1. So now if I plus 1, J plus 1 also palindromics, it means this string is palindromic. So that's been said. So we need to actually start from here to fill on table instead of the top. Because for our entry, for example, when we are here, sorry, let me take another position. So if we are here, we need to look at I plus 1 and J minus 1, which is here. So we need to know this entry first to be able to fill on this one. Same thing for here. If our current position is right here, we need to know the position of I minus 1, I plus 1 and j minus 1, which is right here. So we need to fill out this table from the bottom to the top. So let's do it. So look at when we are here, then when we are here, we check A and B, we see A and B are not the same. So what should we do? We need to take so it means the longest palindromic either happens on this substring or this substring. So we are going to take the maximum of this index and this entries and this entries. So which is 1. Then we move on the next one. So B. So here is B and then here is A. They're not the same. So we take the maximum of this one and this one is still 1. Then B and B are the same. Now since B and B are the same, as we said before, we need to look at the index of I plus 1, j minus 1 to see if it's palindromic. If it is, then we increase the length by 2. So here is A and A is 1. So if we increase the length by 2, that would be 3. Then we are here. So B and B are the same. So we increase the length by 1. Here is 0. So we increase by 2. So it's 2. Then from here, B and A, they are not the same. So we take the maximum of these 2. So that will be 2. Then B and B are the same. So we take, we look at here, since it's palindromic, so we add 2 for the current position. So that will be 3. Now here, B and B are the same. So we look at I plus 1 and j minus 1. So here's 0. 0 plus 2 is 2. And then B and B are the same again. So we plus 2 from here, we plus 2. So we get 3. Then B and A are the same. So sorry, B and A are not the same. So we take the maximum of these 2. So 3 and 2, the maximum is 3. Then B and B are the same. So we add 2 from here. So it's 4. Now we can see from here, the final entries will get the length of the longest palindromic subsequence. All right, so let's start with the coding. So first we need to get the length of the string, and then we need to initialize the table with size n times n. So table equal 0, 0 times n for let's go in range n. And keep in mind the diagonal is, so the entries in the diagonal are all 1. So let's initialize it for I in range and table I so equal 1. So let's start to traverse to the string for we use start as the starting point in range of n minus 2, minus 1, and minus 1. So why here is n minus 2? Because we are start from the second column, and yeah, we are not second column. We are start from the bottom to the top, and then it's like since the first from the diagonal, the last entries in the table is already filled. So so we start from n minus 2. And for each endpoint in our substring, we start from the start plus 1 to the end of the string. So let's check if the string start point is equal to the end point. Then we need to check the previous one to see if it's palindromic. If yes, and then it is palindromic, and then we just need to add the length. So let's show you why is how to check it. How you still remember this example. So for example, our starting point is 8 and endpoint is 8, and then we need to check the middle to see if the middle is palindromic. So if yes, and then the whole string is palindromic. And so how this is start, and then here is n. So the next one would be our start plus 1, and then here is n minus 1. So that was table or equal to table start plus 1 and n minus 1 and plus 2. We increase the size by 2. Else, we need to check either the bottom or the left. We take the maximum of these two. So the bottom will become plus 1, and the left will n minus 1. And at the end, we just need to return table 0. The last entry is n minus 1. Let's run it. Looks good. Right, so it looks good. And let's see the time complexity. So here we check here table of ends, and here we traverse the table by using 2 for loops. Here that will table of n squared, and then in terms of the space complexity, since we use table of size n times n to store the entries, so that will table of n squared. So this is this question, and thank you so much for watching.